Hey friends, today I'll be teaching you a number pattern, and on a number pattern I'm going to only focus on a quadratic sequence. So guys, as you actually know that in grade 12, or let me say for CAPS level, because even grade 11, right, we only have a quadratic sequence, not a quadratic series. Basically we do have a quadratic series, but it's only found at the university level. If you are going to major with maths at the university level, then it's whereby now you are going to encounter your quadratic series. The reason being is because we do have the suitable formulas that can allow us to solve a quadratic series, but for CAPS level we don't have suitable formulas that can allow us to solve a quadratic series. So let's focus on our quadratic sequence, right? Okay guys, before I proceed, just click on the subscription button so that you can be able to always get notified whenever I upload a video as we proceed. So we have what we call it a quadratic sequence. So for a quadratic sequence, you will need to expect the question that will say determine the nth term or the general term. We have what we call it a general term. We have what we call it a general term, a general term. We have what we call it a general term. So a general term for a quadratic sequence can be given in the form of Tn equal to an squared plus bn plus c. So this is a general term, but don't get confused if you see that your general term is given, because this n can be replaced by any alphabet. Sometimes your tn your tn, which is the general term, so they call it a general term or an nth term. Sometimes they can just say your nth term, determine your nth determine your nth term. Sometimes they will say determine your the nth term, the nth term. This is n, guys, this is n. They will say determine the nth term or the general term. The nth term is the same thing as the general term. So your n can be replaced by any alphabet. Your n can be replaced. Sometimes they will say determine your general term in the form of tk equal to a k squared plus b k plus c or plus q. So your k can be replaced by, your n can be replaced by any alphabet. Don't get confused if you see that your n is replaced by k or by any alphabet. You just need to expect your n to be any alphabet. So let's proceed. Sometimes, okay, let me just give you a number pattern so that I can be able to solve it and show you how to determine the general term for a quadratic sequence. So your quadratic sequence can be given in the form of 3, then 8, then 15, and also what? And also 24. So this will be your number pattern. This will be your sequence. This will be your sequence, right? So for a quadratic sequence, in order for you to get your common difference, we will get your common difference on your second difference. You will get your common difference on your second difference, meaning that in order for you to get your common difference, you have to subtract the consecutive terms by finding what? By finding your first difference. Then from a first difference, then you will get your common difference. So let's find our first difference. This will be our first difference. So we are going to say, in order for you to get your first difference, you have to say term number 2 minus term number 1. We have term number 1, term number 2, term number 3, and also term number 4. So we are going to say term number 2 minus term 1. In order for you to get our first difference, you have to say term number 2 minus term number 1. So term number 2 minus term number 1, and also term number 3 minus term number 2, in order for you to get the next value, right? So let's find our first difference. 8 minus 3 is equal to 5, meaning that here we have 5, here we have 5. Let me put our 5. 5, then 15 minus 8. 15 minus 8 is equal to 7. Here we have 7, right? Then 24 minus 15. 24 minus 15 is equal to 9. Now we have our first difference. This is our first difference. Then let's find our common difference. So you are going to get your common difference on your second. This is a common. This is a common. This is a common. Now we are about to get our common. Our common. Now we are about to get our common difference. Now we are about to find our common difference on our second difference, right? On our second difference, we get our common difference on our we get our common difference on our second difference. On our second difference, then let's find our common difference. Then we are going to get our common difference by saying this term, which is our term 2 minus term 1. So term 2, here we have term 2 minus term 1. So 7 minus 5 is equal to 2. Is equal to 2. Is equal to 2. Is equal to 2. 7 minus 5 is equal to 2. What about term number 3 minus term number 2? 9 minus 7 is equal to 2. 9 minus 7 is equal to 2. Now we have our common difference. This is our common difference. Therefore, our D is equal to 2. Then, now let's determine the values of A, B, and C. In order for you to get the value of A, you have to say 2. A is equal to what? Is equal to our first term on our common difference. 2A, this 2 is a constant. It's always there. It's always there. You have to say 2A is equal to our first term on our common difference. On our common difference, equal to our first term on our common difference. Second term on, the first term on, you have to equate this 2A to your first term on your common difference, meaning the 2A is equal to 2. Then divided by 2 both sides. Therefore, our A is equal to 1, because 2 divided by 2 is equal to 1. Then let's go for our value of B. Let's look for the value of B. 3A plus B, which is equal to what? Which is equal to our first term on our first difference, meaning that you have to say 3A plus B equal to 5. Then let's find the value of B. We have our A, which is equal to 1, then plus B equal to 5. Then we have 3 multiplied by 1, which is equal to 3, plus B equal to 5. Therefore, our B is equal to 5 minus 3. Therefore, our B is equal to what? 5 minus 3 is equal to 2. Therefore, our B is equal to 2. Then let's find the value of C. Let's find the value of C. In order for you to get the value of C, you just need to say A plus B plus C. You need to say A plus B plus C is equal to what? Is equal to our first term on our original number pattern, equal to this 3, equal to 3. Just need to equate A plus B plus C to your original, to the first term on your original number pattern. Mean that for A, you just need to, in order for you to get the value of A, you just need to say 2A equal to this. For B, you just need to say 3A plus B is equal to this. Then for C, you just need to say A plus B plus C equal to first term on your original number pattern. This is our original number pattern. This is our original, then first difference, and also our common difference on our second difference. So this is our value of A, B, and C. So our value of A is equal to 1. Then we have 1 plus B. Our B is equal to 2. This is our B, which is equal to 2. plus c. Then 1 plus 1 is equal to 3 plus c. Therefore, this whole thing is equal to 3. This whole thing is equal to 3. Therefore, our c is equal to 3 minus 3 is equal to 3, then minus 3. If you transpose this 3 this side, then you get 0. Therefore, which means our c is equal to 0. Right? Therefore, now let's determine our general term. So our Tn is equal to a. The value of a is equal to 1, meaning that we have 1 multiplied by n squared plus b. Our b is equal to 2, meaning that we have positive 2 multiplied by what? Multiplied by n. Multiplied by n. Then we have the value of c. Our value of c is equal to 0, meaning that we have plus 0. Then simplify your equation. Our Tn is equal to 1 multiplied by n is equal to n squared. Multiplied by n squared is equal to n squared, right? 1 multiplied by n squared is equal to n squared. Then plus 2 multiplied by n is equal to positive 2n. Then plus 0. Our 0 is there. So there is no need for you to write 0. So this is our general term. This is our general term or the nth term. When the examiner says determine the nth term or the general term, they mean you have to determine this equation, right? Yes. So you just need to expect those questions. Yes, you just need to expect those questions. Even if the examiner says determine the value of b, you just need to, because we have our a, b and c, you just need to follow the same procedure. Sometimes they will say prove that, or let me say, they will say show that the value, or let me say the nth, or the general, show that the general term, the general term, the general term can be given in the form of Tn equal to maybe 6n squared plus 8n plus 9. I'm just making an example. If they say show that your Tn can be given in this form, you just need to follow these steps. Follow all these steps. Use your original number pattern to find your first difference, and also followed by the second difference. Then follow these steps. So your number pattern will be different. Obviously, it will be different from this one, because this one gives you this general term. But for that particular number pattern, or let me see, that particular quadratic sequence that will be given during that exam, it will definitely give you this equation. If they say you have to show that your equation is given in this form, so you just need to follow these steps and you will get this equation. You don't have to touch this equation. You just need to follow the steps. Those steps will give you this equation. If it will give you your final equation. Even if they say they show that the value of c is equal to this, you just need to follow these steps. Use your original number pattern. Follow these steps. Though, like, these steps will give you a final answer, which is equal to this equation, right? So this is just an example. This is just an example. If the examiner says determine the next term, meaning the term number 5, you just need to add what? You just need to add, let me show you. Okay, in order for you to get term number 2 is equal to 3 plus 5. So meaning that in order for you to get term number 2, you just need to add this plus this. They will give you this. If in term number 3, in order for you to get term number 3, you just need to add 8 plus 7. 8 plus 7 is equal to 15, meaning that you just need to check the lines that are in this form. You add this plus this to get this. You also add this plus this to get this, right? That's how it works. That is a pattern. You add this plus this to get this. you also add this plus this to get this. Even to get this, you just need to add 15 plus 9. You'll get 24. Then in order for you to get term number 5, you just need to start from, we know that this second, like our common difference, at our common difference, we have 2, even here is going to be 2. So you can just put your 2 in, put these 2 lines. So meaning that in order for us to get this term, we just need to add this plus this. Because in order for you to get this term number 7, in order for, not term number 7 actually, in order for you to get 7 is equal to 5 plus 2. In order for you to get this 7, you just need to add 5 plus 2, you'll get 7. You just need to check the lines. Add this plus this, you'll get this. 7 plus 2 is equal to 9. 9 plus 2 is equal to 9, 10, 11 is equal to 11. Then now we are about to get our 5th term. So in order for you to get this term, you just need to add 24 plus 11. 24 plus 11 is equal to 35. Is equal to 35. So if you subtract 35 minus 24, you are going to get 11. Then 11 minus 9 is equal to 2, right? Yes, that's how it works, guys. So that is the approach. So guys, don't forget to like and also subscribe on my YouTube channel so that you can be able to always get notified whenever I upload a video.